hi everyone, my name is Bethany Griggs, and I'm excited to be here in New York. I've traveled over from the UK, and today I'm here to talk about the fun of debugging version upgrades, in particular Node.js upgrades. To start, a quick little bit about myself. I am a senior software engineer at Red Hat, and I spend a lot of my time contributing to the upstream Node.js project. The rest of my time, I get to work with all of the product teams at Red Hat and IBM using Node. I am on the Node.js technical steering committee, but mostly active in the Node.js release working group. That means I spend a lot of time helping build releases on the same team as Danielle, who you may have seen her talk earlier. So in case you missed any of the release news in the Node project recently, earlier this year we had Node.js 18, which was released. That was in April, and that was big news because it was a long-term support release. So one of the releases the enterprises will likely get their hands on and use. And also more recently, we have Node.js 19. And that was released in October, and that's currently our current release. So it has all the new features and the latest updates that are landing in the project. So, two big new versions. The exciting thing that most people get to are, yay, new features. So yep, great new features. Everyone's excited for new features. And in Node 16, and Node 18, sorry, we introduced the global fetch API. This was a very anticipated API. Discussions go back years. We finally landed it, shipped it. It's still experimental, but it's good because conceptually, people using fetch in the browser have something similar in Node that they can use. There's some performance tweaks we need to do, but people are working on it, and it's getting lots of use already. And then we also have the built-in test runner. So this was in Node 18. We introduced a test runner, and this means you don't have to go off and install a module to test your applications anymore, because you can use the built-in one. And the purpose of this isn't to displace, all of the great test frameworks out there like Mocha, Jest, and those. It's just to provide something small and lightweight that covers a useful set of use cases. So if you've just got a small app, you maybe won't have to go out and install one of the modules. The way I see it being used is, yes, I start off using this, and then once my app gets complex enough, I need to go and explore some, advanced features. Then I would go and pick up like Jest or one of the other modules. Lots of great work, particularly from Colin on that one. And we also, even more recently, landed Watch. So you can now watch files for updates, and they will reload and rebuild and rerun. Great. Think NodeMon. If you've used NodeMon, we now have similar implementation in Node. So that's lots of, cool new features. The kind of carrot on this, stick to encourage people to upgrade. But I know this is not the reality. Upgrading versions takes time, it takes effort, and it takes money. I work with a lot of enterprises where it's still the traditional life cycle. You're not deploying every single day like many of the cool companies are. You've still got long, development processes. You've got code freezes. It takes time to upgrade. And you really have to find a window in all of your other priorities to have time to do the update. And this means inevitably it kind of gets pushed to the last minute until you're forced to upgrade because you're approaching the end of life. And that's why I'm here today. I'd like to share some techniques, what I've learned from helping teams at Red Hat and IBM upgrade their Node versions. And the flow of the talk is going to be, I'm going to start off with what may seem obvious, and then go into maybe some more involved techniques. My aim is that hopefully you'll learn, at least one technique that you didn't before. So the first good piece of context to have is to understand how Node.js releases work. Fortunately, Danielle did a great talk this morning that covered that, so if you caught that, perfect. But if not, I'll just recap the very, very high-level basics that are necessary for this talk. First of all, the Node project follows semantic versioning, the semantic versioning contract. So I'm sure many folks are familiar, but the first number is incremented for a breaking change, the second for a feature, and the last for a fix. But that comes with some caveats. So you can argue all day about the difference between a bug fix and a breaking change. We've actually found cases where there are genuine bugs in the node runtime, but people are relying on the behavior. So we can't actually ship it as a traditional bug fix. We have to delay it and ship it in the next major, literally because it would just have too much impact. Same applies for spec incompatibility. In some cases, you may think, making this API align with the spec is just a bug fix, but actually it would have such wide impact, we elevate it to a breaking change. We also have a blanket exception for critical security fixes. So where we maintain multiple release lines, we have to ship our security fixes, even if they are technically a breaking change. So in our policy, if something's security conscious, we will ship it in an existing major release line. We often do try to give you workarounds, like a command line flag, to revert back to the old behavior, just so you can still upgrade. But this is what we do. And then last of all, very unexpected side effects. We try to adhere to this contract. We put PRs in. We label our PRs with their FINOS. But to be honest, we make mistakes. Sometimes things have unexpected changes. And that leads me into the release schedule. So Danielle did a good recap of this. The main takeaway for this talk is we have current and long-term support releases. Generally, for most businesses, due to the length of time it's supported, they will stick to the long-term support releases. So the even-numbered release lines, node 14, 18, and 20, soon to be 20. So the main context here is current releases are kind of like betas to try out the cutting edge. The LTS releases, even-numbered releases, are the secure and the longer-term supported ones. But what this means when you come to upgrading, if you're in an enterprise setting, is you inevitably end up doing a double jump. So you actually typically go from like 14 to 16 or soon 16 to 18. And what that means is you've picked up a lot of changes in the meantime as the code's churned. As Daniel mentioned earlier, the main branch evolves as these releases are cut. So you've probably got about a good year's worth of changes to pick up if you're going between 14 and 16. And this is relevant because it leads me into the first port of call when you're debugging a breaking change. And that's to look at the change logs. But you need to know which ones to look at. And if you were going from, say, node 14 to 16, you'd actually need to look at both the 15.00 changelog and the 16.00 changelog because they're cumulative. You're picking up all the breaking changes between those two versions. So if you've got your app and suddenly it breaks with the upgrade, the first thing I would do is check these two changelogs. In theory, everything that's identified as a breaking change will be in those changelogs. I've got some good news here, though. This is the number of 7 major PRs per release line. As you can see, it kind of peaked around node 10. And after that, we're heading back down in numbers, just less than 50 PRs that are breaking changes. Stability. This is because, Node's a mature project at this point. Stability is key. So over time, we're being more conscious about making breaking changes. Once you're in the changelog, another useful tool is our use of subsystems. So a subsystem is kind of an area of the project that the code touches. As contributors to the Node project, we try to identify all our commits based on these subsystems. And this is useful for end users in a changelog because, say your HTTP server is broken, you can use it as a shortcut to try and identify which changes are likely to be the problematic ones. This is great when there are intentional breaking changes with known impact. So one I think we did really well was the OpenSSL 3.0 upgrade. Due to lifetimes of OpenSSL, we had to make this breaking change. But what we did, we could explain why we needed to make the change. We gave some options for people to revert and work around any new behaviors in OpenSSL 3. For context, OpenSSL, when it does new majors, they tend to block some older algorithms and say you can't use MD4 anymore, so your application would actually fail. And we provided the OpenSSL legacy provider command line so you can revert back temporarily. But things are really not always this smooth. debugging upgrades, you can't always infer it from the changelog. And now I'd like to segue into one of my work experiences. So at the start of the year, I was tasked with helping a team update their JavaScript client for their product. It's a Java-based team, a lot of Java engineers. They just happen to have a JavaScript client, so they didn't really have the expertise of Node runtime. And the project was called FINOS. It's an open source data grid. Think it's just a Redis kind of equivalent. It backs the product Red Hat data grid if you're a Red Hat customer. And they needed to support Node 16. So they reached out to some folks in our team who maintained the runtime because they had the context to do so. So I started with some very, very obvious steps that I'm sure most folks would do. You run the test suite with one version, it passes. You run it with the next version, it hangs. And 15 also hangs. And what I do to do this, I just use NVM, switch between versions, and run the test suite, see what happens. Another typical debugging step is to isolate the individual test. So in this case, the whole test suite was hanging. I just needed to go in and figure out what the exact test was. And this does have some relevance later. So what the failing test was, it was a cross-site test. So essentially, it starts two clients, expects to be able to read and write to both. It destroys one of them, tries to write to the one that destroyed, and what should happen in theory is under the covers, it successfully persists the data, but goes via the client that's still living. So that was the context of the test. And then I went to the very, very typical, familiar debugging step of sticking console logs everywhere to see what would happen. Very familiar. This was good because I could roughly see what part was hanging. Great. And then I was like, actually, I should be a bit more intentional about my debugging here. Let's use a better tool for this. So I pinged open the Google Chrome Inspector. So I started stepping through the code. What's happening here, stepping through. And what I hit at this point is, this was an events problem. And stepping through the code just meant I was stepping through the event loop until the timer ran out, and that was it. Like, this wasn't giving me helping me diagnose the problem. All I knew is it was waiting for something to happen that never happened. So at this point, I was really trying to think, what next, what to do? So I resorted to git bisect. And this is a binary search algorithm that you can use to find where a problematic commit was introduced in your Git history. So as Daniel mentioned, the release group do this quite often because when we're building releases, we need to check, if a test fails, we want to check which commit is causing that failure and pull it out before shipping the release. But in this case, I used that technique to find out which breaking change was impacting our client. And so you give it a good and a bad commit, and then you start the git bisect process. And now I have a demo-ish. If you give me 1 second to bring it on to the screen. Or not. Bear with me. I will get it. There we go. It was a lot harder than I made it. There we go. Right. And it's really hard to type when what you're looking at is doing that. So I don't trust a demo god, so I always record all of my demos in ASCII, which will just play back all my commands. So this is the exact bisect I used to debug this problem. So you start by calling git bisect start. You supplied a good commit. In this case, the commit was node 13 release commit, because I knew it was in the window. And I knew the bad commit was node 15 release commit. And this is all on the main branch. And then at each level, I have simulated this, because if I built and tested Node at every step here, we'd be here for at least an hour. So I just ran through and simulated it. So what I would do at each step is run make build, and then run the individual test with my custom binary for that particular commit. And as you can see, it starts running through the steps. And git bisect does actually have, you can pass it a script instead. like a shell script, and it uses the exit code of the shell script, so I could just type git bisect run test.sh and walk away. But I find this quite intuitive to demonstrate. So great. I found the problematic commit, which is net auto destroy socket. And based on the test, at this point I was getting some familiarity with this is probably a socket or streams type error. And now I will quickly go back to my tool. This is good. OK. So yay, I found a problematic commit. Net auto destroy socket. OK. Bearing in mind the context that the people I'm working with are Java engineers who maintain a small JavaScript client, it may be great to find a commit, but you need a lot of context to be able to go into the node core runtime and be like, hey, why is this commit impacting my small client? Because this is low-level stuff. So even myself, when I was looking at it, I was like, I kind of see what's happening here, but I can't quite articulate why this is causing the breakage in the same way in my client. So again, had to sit back and think, what's next, what's again? And so I tried node debug. And I don't know if anyone's aware of the node debug environment variable, but if you supply that to your node process, you can get some lower level runtime values out of the debugging output. And going back to what I said about the changelogs, we use subsystems here as well. So if you wanted to see all of the debug level logs for HTTP or net or stream, you could just do node debug equals one of those, and you would get the low level output. You can also enable all with a wildcard, but to be honest, don't do that because you just see timers counting down and it's not useful. And then I got to the point where I could run with this low level output with node 14 and node 16 and see the stream and net events. I chose stream and net because I knew from the commit it likely touched net or stream. And again, it was going through, and I could kind of see what was happening. One side was just waiting for something to happen, and a certain event wasn't being emitted. Again, this was a couple of weeks of work just being like, I don't know what's going on. I'm getting closer, but I still have no idea what's going on here. So then I was like, ask the experts for help. And I reached out to one expert. I was just like, how do you debug streams? I have no idea how to do this. How do you do it? And one did suggest that I had a few beers and then tried it after a few drinks in an evening to avoid the despair of looking at streams code. So that was one suggestion. That wasn't their only suggestion. The next suggestion is what really helped me plug all the pieces together, which was to create a minimal node core reproduce. So at this point, I'd spent literally days, almost weeks, stepping through this code, trying to figure out what was going on. And from all of that, I'd gained context of roughly what it was doing at a high level. So taking all of the specifics of the clients and the infinite span out of it, what was happening here? And it was really just quite simple. It was like it was creating a socket, destroying it, and then trying to write to it after it was destroyed. What I know is that there's some behavior difference in node 14 and 16 with this. Why? Oh, wow, apparently it had, OK. So I created a minimal reproduce. So in here, we create a socket, logs connected when it's available. I just used timers because I thought it was quite easy to demonstrate here. So you send a destroy message to the socket, and it destroys after 3 seconds. After it's had time to be destroyed, I just sent, hello world to it. And I found this few lines of code emits an error in node 14, but it actually doesn't in node 16. So that was the key difference. And then I could eventually get to what the code needed to be to still emit the error. And as you can see here, it was a case of just emitting it via the callback. So this was the most minimally invasive way of adjusting the code in the project's client to get similar behavior in node 14 and 16. What was actually happening is the test suite was hanging because it was waiting for that error event. It was never happening, and therefore we needed to manually elevate it and expose it. And that's what enabled the fallback behavior to, it tried to write to client B. That error wasn't coming back, and it was only once I forced it to give the error back, the client knew to write to client A instead and do the fallback cross-site behavior. And their incentives said, it was a bit of a flaky client written on some bad assumptions potentially, but in context of, just trying to get this client working with the least amount of change and least amount of risk, this was the solution here. So just to summarize my techniques, and I'd probably use this path again going forward, is I'd first isolate the test failure and identify the specific version that introduced the breakage. I'd then look at the changelog being guided by the subsystem. Obviously use our traditional debugging tools such as console logs, Google Chrome dev tools, etc. But then the more involved steps are to look at runtime level debugging with the node debug variable. You can resort to a git bisect of the node runtime. And you may ask, why didn't you just do that straight away? One, it takes a long time unless you have access to a powerful machine. I think it was 1,800 commits I was bisecting between. So it can take a lot, and builds of Node could take, depending on your machine, 20 minutes or maybe a bit quicker. So it would take a long time. And also, had I not spent so many hours stepping through that test, really understanding what was going on, finding the commit probably wouldn't have helped that much without the additional context. Also, ask the experts for help. We have teams on the Node project who are responsible for certain areas. So you can reach out to the group that are responsible for streams or the group that are responsible for the console or something. So knowing who to ask to help says for a lot. And also a minimal node core reproduce. And I give that the gold medal, it's the easiest thing to go from what's the change in the runtime and how is that impacting my application. And what I will say is, if you do have a minimal node core reproduce, you're still unsure if it's an expected or unexpected change. That's perfect. That's the perfect thing to hand to a maintainer because they've got all the code. They know it's not an issue in your personal code or your company's code. They've got the minimal set. They can prove and confirm if it's an issue or not. So now that's what the process I would follow. How can you prepare for an upgrade? The key tip I always say is lots of companies only use the even numbered releases, the long-term support releases. I would suggest, even if you don't intend to support or use internally the odd-numbered release lines, maybe add it to your test matrix when it's released, because then you're just getting some early feedback. You don't need to fail completely on it. But instead of doing that double jump, if you, in this case, if this team had added node 15 to their matrix, they would have learned when that was released that they were going to be hit by the change, the window's smaller, it would have been easier to debug. So that's my normal first suggestion. I also want to share, there's a GitHub Actions config. It's in the pk.js GitHub org, which is actually a Node.js project-owned GitHub org. And what this GitHub action does is it automates which Node versions are in your CI flow. So instead of putting a PR in to add 16, a PR in to add 18, it automatically, you can give it a value of LTS, at which point the matrix, it will generate the matrix and run on all LTS versions. And why I mention this is there's also a setting where it will cover all of your LTS versions plus the current. So at the moment, it would do 14, 16, and 18. But it would also do 19 as your kind of early feedback on how much you're going to be impacted by the upcoming release. I'd also like to give credit to Dominicus. He did a lot of work on this. He works in Nearform. Another thing you can do is to try running your application with the pending deprecation flag. So when we're looking to deprecate or remove some APIs, we will sometimes register this within the code itself. So if you run node myapp with this pending deprecation flag, and you're using an API that may be removed in future, it will actually error and show you, say, hey, you're using an API that's due to be deprecated in a future release. Again, you wouldn't do this all the time. You would do this to get some early feedback on what you're going to be impacted by. And what I would say is if you are hitting a problem upgrading, please do open an issue or a discussion. Mostly because it could be an undocumented change. As I said, where it starts, things can have unexpected side effects. What we can think could be a purely additive feature, may actually cause breakage that we just weren't aware about from your use case. And it also could be the fact that, if you're asking, it's probably that we haven't documented it or not documented it well enough. And if we can get that feedback, improve our documentation, it helps the upgrade experience for every user. And it also, I think the most important one is, this really helps us assess the ecosystem impact of the similar changes in future. Say, for example, this change, all our tests look fine. It caused real breakage in real-world applications. We know next time when there's a similar commit like this that touches similar areas, there is a consequence that may not be covered by, our low-level unit tests. And what I would say, you get bonus points if, when you are hitting a problem upgrading, you can come with us to a small reproduce, because that, in terms of how much time maintainers have, having a small reproduce is really what helps us help you. And with that, I will close out. I'm happy to chat one-to-one about any debugging problems, version upgrades, issues. But yeah, thanks for your time, and I hope you learned at least one way of debugging an upgrade.